Today I would be doing two reactions simultaneously. One is the reaction of aluminium with caustic soda, which is also called sodium hydroxide, and a reaction of aluminium with hydrochloric acid. All that we need for this reaction is some hydrochloric acid, some sodium hydroxide, and aluminium in the form of aluminium foil and 2 beakers. All that would be happening in this reaction is that 2 moles of aluminium react with 6 moles of hydrochloric acid in diluted form to give us aluminium chloride, and hydrogen gas is also evolved out here. And in the second reaction, aluminium reacts with sodium hydroxide in aqueous medium to give us something called sodium aluminate, which is NaAlO2, and some hydrogen gas is also evolved. In literature, it is given that this complex out here also may also be formed, which is called sodium tetrahydroxyl aluminate. So this is what would be happening in the reactions which I would be doing now. In both the cases, there's a similarity that hydrogen gas is evolved, and in both the cases, the metal is aluminium. So let's see which one is a better reaction in terms of its vigorousness and in terms of its effervescence. So let's start. First of all, we need to make a solution of sodium hydroxide. I will be taking some sodium in this beaker out here, and we need to add some water to it to make a solution of sodium hydroxide. Addition of water to sodium hydroxide. Sorry for the disturbance over there. Addition of water to sodium hydroxide is very exothermic, and sodium hydroxide takes quite long to dissolve in water. Using a stir rod, give it a good stir. You can see that there's some steam which has condensed on the walls of the beaker. The heat which was evolved in the reaction caused the water to evaporate. I'll show you when I'm done. I've made 45 milliliters of sodium hydroxide solution. It doesn't matter if it's a bit cloudy. So this is what the solution turns out to be. And I'll be adding it to one of the beakers over here. And I've taken 45 milliliters of hydrochloric acid in this beaker. I will be adding this to this beaker over here. So make sure you put your safety gear on while handling caustic bases and corrosive acids. Now you need to add some aluminium to each of them. I've made some balls of aluminium of the foil. There's one thing which would be happening when we use aluminium foil as a source of aluminium. There's a formation of this layer of oxide which is on the aluminium foil. So it takes some time to for the reaction to start. As you can see, the hydrochloric acid reacted very vigorously, and the reaction has proceeded very quickly, and sodium hydroxide is taking its own sweet time for the reaction to proceed, but you can see that aluminium over there is also reacting. I would hold a burning splinter at the mouth of the solution of this beaker. That was very loud indeed. This was because all the hydrogen which was there were combusted in the presence of oxygen to give water, and you can see almost the entire aluminium has reacted, and I would hold a burning splinter to this speaker as well. This was loud too. The loudness was quite same for both the reactions, because as per me, I think that the volume of hydrogen which was there was equal in both the cases. So I think the loudness is same due to this reason. And aluminium in the hydrochloric acid solution has reacted completely, and here aluminium in the sodium hydroxide solution is taking a bit some time to react. Sorry for that. You can see the hydrogen gas which is being evolved. The best thing I liked about this reaction was the pop sound, which was very loud. So the aluminium in this beaker, which contained sulfuric, sodium hydroxide, also has been consumed almost entirely. So I think the winner over here must be hydrochloric acid, because if you want to dissolve aluminium or react aluminium, hydrochloric acid is better when we have sodium hydroxide and hydrochloric acid. As you guys had seen that with hydrochloric acid the reaction was almost instantaneous, but with sodium hydroxide it took some time. And that's all from my side in this video. Thanks for watching. Please do like, share, comment, and please do subscribe. And please do support my Patreon page, for which I will provide a link down in the description. Thanks for watching.